In this video, we're going to go through derivatives and so let's get started. If we have a function f of x and we take its derivative function is denoted by f dash x, okay? Now, in reality, there's many different ways of denoting the derivative. There's things like dy dx and all that type of stuff, but for simplicity's sake, I like to call it f dash x. So for now, we have a function, we take its derivative, and we get another function, which is its derivative function, and we're going to call that f dash x, okay? So let's get started. How do we actually calculate derivatives? So if we have a function here, f of x is equal to x to the power of n, where x and n can be any real numbers, we calculate its derivative. It's a very simple process, just pay close attention. We have x to the power of n, right? So first what we do is we bring this index down to the front, and we minus 1 from the index position. So then we denote the derivative function, f dash x is equal to, when we bring the n down, we get n multiplied by x to the power of n minus 1. And that is simply your derivative function. So let's move on to a quick, easy example. We have f of x is equal to x to the power of 4. Now if we wanted to take its derivative, we would denote the derivative as f dash x is equal to, we bring this 4 down to the front, and we minus 1 from the index position. So then we'd get 4x to the power of 4 minus 1. Therefore, f dash x is equal to 4x to the power of 3. And that is your derivative function. So yep, it's a fairly simple process, and these are some example questions to strengthen your knowledge. Feel free to pause the video and have a go at them yourself. If not, then I'll be going through these with worked solutions. So let's get started. We have f of x is equal to x squared. Now we denote the derivative as f dash x, and this is equal to, remember, we bring the 2 to the front, we minus 1 from the index, and this just equals 2x to the power of 1. Therefore f dash x is just equal to 2x, because we generally don't write powers of 1 in maths. So f dash x is equal to 2x, and this is your derivative right here. Okay, question number 2. We have f of x is equal to 6x plus 4. So first what we do is we calculate the derivative of 6x, and then we carry this sign across, and we calculate the derivative of 4. Okay, so first we denote the derivative as f dash x, and the derivative of 6x is just 6. And let me show you why. So let's pick this color. 6x is just basically the same as 6x to the power of 1, right? And if we were to take the derivative of this, we'd bring this 1 out to the front, multiply it with the 6, and we minus 1 from the index position. So then this would just give us 1 multiplied by 6, x to the power of 0. And 6 times 1 is just 1, so it equals 6. And then x to the power of 0 is just 1, so it's just 6 times 1 equals 6. And that's why the derivative of 6x is just equal to 6. Okay, so let's just move on now. And then we carry the sign down, this plus sign, and we calculate the derivative of 4. And it's important to note that the derivative of any constant, any term that doesn't have a variable attached to it, is always just 0. Okay, so the derivative of 4 is just 0. Therefore, f dash x is equal to 6. Okay, so next question. We have f of x is equal to x squared plus 2x plus 5. Now we denote the derivative as f dash x, and we calculate the derivative of x squared. The derivative of x squared is just 2x. The derivative of 2x is just 2. And the derivative of 5 is just 0 plus 0. Therefore, f dash x is equal to 2x plus 2. And this here is your derivative function. Next question, we have f of x is equal to x squared plus 10x plus 2. Now f dash x is equal to, the derivative of x squared is just 2x again. The derivative of 10x is just 10 plus 10 plus, and the derivative of 2 is 0. Therefore, your f dash x is equal to 2x plus 10. Okay, so next question. We have f of x is equal to square root of x. And in this case, we need to slightly manipulate this function over here. So square root of x can also be written as f of x. It can also be written as x to the power of a half. Okay, now that we have an index over here, we can always calculate the derivative. Therefore, f dash x is equal to, we bring this half down to the front, and we minus 1 from the index position. So this then equals half x to the power of negative half, because 1 over 2 minus 1 is negative half. Okay, next question, we have f of x is equal to 2x squared minus x to the power of 4. So we denote its derivative as f dash x, and to take the derivative of 2x squared, we bring this 2 out to the front, minus 1 from here. So then this then equals 2 multiplied by, because we brought the 2 down, 2 multiplied by 2x to the power of 1. And next, it's an important step to carry out this minus sign down to our derivative function. So we have to write a minus. It's very important you stay consistent with those. And we have to calculate the derivative of x to the power of 4. And this just equals, we bring the 4 down, we minus 1 from up here. This just equals 4x to the power of 3. Therefore, f dash x is equal to 4x minus 4x to the power of 3. That's a derivative function. Question number 7, we have f of x is equal to x to the power of a half. Remember, to calculate the derivative, we bring the half down and we minus by 1. So then we get f dash x is equal to half x to the power of negative half. Okay, so that's your derivative. Next function, and this is an important rule you need to remember. We have I'll just write it down over here. If f of x is equal to e to the x, then f dash x is also equal to e to the x. Okay, so the derivative of e to the x is just e to the x itself. And there is a reason behind this, and I'll explain this in another video because I don't want to overcomplicate anything. But for now, just remember that the derivative of e to the x is just e to the x, okay? So yep, these are the 8 questions and their worked solutions. This should hopefully give you enough information to go and have a go at your textbook questions, get some practice, and have a go at your past exam papers. And just keep in mind that these are just very simple derivatives, so this is foundational knowledge, and in the upcoming videos we're going to go through other ways to calculate derivatives, such as first principles. I'll just write this properly. First principles. We'll go through chain rule. We'll go through product rule. And we'll go through quotient rule. And just keep in mind, these are all just different ways to calculate derivatives. They all involve some sort of formula. So yep, it'll get slightly more rigorous when calculating derivatives using these.